Hi, I'm Lino Grandi, 3D artist from Otoy, and in this video I'll describe the materials you can find in Octane Render. Let's get started. Materials are a very important part of Octane Render because materials let you define all the characteristics of the surface of an object. We have several kind of materials. We have the diffuse material, the glossy material, the specular material, the portal material, the shadow catcher material, the tone material, metal material, universal material, and the hair material. In my workflow, I prefer to use the universal material for almost everything I do, but it's very important to know what the other materials are, especially because we have the possibility to layer down different kind of materials, and this can be achieved using the diffuse layer material, the specular layer material, and so on. So it's very important to know the way all materials work. So let's start adding a material to the object in the scene. So just click on New. I'm going to assign the same material to the sphere mesh as well. So, this way we can see the effect on a complex object and on a very simple one. And yeah, as you add a material, as you create a new one, the universal material is automatically created. You can change that if you go to the preferences and look for Octane. You will see that you're able to specify the default material type. It can be any material available. Again, I choose universal because that's the one I so often use in my projects. By the way, I'm going to delete it so I can add the diffuse material. So the diffuse material is a material used basically for dull and non-reflecting objects, or for light emitting surfaces. There is no specular, as you can see, so it's exclusively dedicated to the diffuse shading. And yeah, so we have the albedo. Here is called diffuse, but it's just another way to call the albedo. And we can change the color of the diffuse. So that's pretty, straightforward. Then we have the roughness option, which works on the diffuse shading. So we can get some different result, some very different result on the shading, just operating on the roughness. Then we have the bump input. There are many attributes that are common to other materials. Bump, it's about, of course, it's about texturing. So it needs a texture. I'm going to add a noise texture just to show how it works. So you can see now we're simulating some relief on the surface. That's some contrast. So basically, with the bump, we're using a map or a procedural texture to change the normal incidence value. It's just an illusion, but it's very good to add details in general. I'm going to detach that, and then we have the displacement. And there are 2 videos about displacement on the NVIDIA channel, so you can watch them to know more about it. Then we have the opacity. The opacity is basically a way to dissolve the object, or better, the material. In this case, the material is assigned to the whole object, so of course it's just dissolving the whole mesh. But yeah, so this way you can decide which part of the object should be hidden. Even in this case, you can use a texture. So if we use some more contrast here, you can see I'm basically cutting out some parts of the object. This is not transparency or transmission, it's opacity, and we can find it you know, in basically in all the materials. So this is pretty cool, very useful. Yeah, then the edge rounding is something we will see in other videos. The transmission, it's used in conjunction with the medium nodes, and it's there to simulate subsurface scattering. So in this case, you know, we're not going too deep into it. You just have to know that if you want to simulate subsurface scattering using the diffuse, you will have to you know, use the transmission value. I'll make a video totally dedicated to scattering in Octane. So there will be, you know, we will analyze how scatter works with all the materials. The shadow catcher option, also common to other materials, is used to, let's make an example. It's used to capture the shadows projected on an object by other objects. I'm going to create a material for the plane here. Let's add a diffuse material. So now if I activate shadow catcher, you will see that it's basically yeah, capturing, now the material is basically capturing the shadows projected by the objects in the scene. So if you have to do some compositing over a background or an HDRI, you can use shadow catcher, which exists as a material itself. So as you can see, so you can attach this directly and have the same result. But again, we have this option for all the materials. Let's attach the diffuse material back and disable the shadow catcher. And let's go on with the next material. So what we have now is the glossy material. So I'm going to attach it and get rid of the diffuse. So even in this case, we have the albedo, the diffuse, so we can change the color as we need. But in this case, we have the specular value, which basically, you know, helps us define how reflective the material is. So it can be totally dull. So in this case, it's like using the diffuse material, but of course we have the possibility to get reflections too. So that's very useful. And the roughness is controlling how rough the surface is. So for very low values like 0, which shouldn't be used in general, because it's always better to never use values like 0 or 1. I mean minimum and maximum values. It's always better, you know, even to just use something like 0.050. It really depends on what you want to get as a result, of course. But in general, my advice is to not use a value of 0 ever for any value. So if we increase the roughness, we will notice that the specular highlight the specular reflection is going to get more diffuse, blurred, and this helps defining the kind of material we want to simulate. All reflective materials in Octane have this new option which allows to change the BRDF model used for the reflection. BRDF stands for bidirectional reflectance distribution function, and it's an algorithm that defines how the light is reflected by a surface. I normally use the GGX model because I find it to be the most realistic. I like the way it reacts, the light reacts to the reflection, and also because that's one of the models that lets you use the anisotropy. Normally the reflectance of a material is uniform in all directions, doesn't change based on the surface's orientation or rotation, so it's basically isotropic. If we want to make it anisotropic, in order to do that we can use the anisotropy value. You may notice that if I start changing the value now, we don't see much difference. That's because the roughness is really low. To be able to see the anisotropic effect, you definitely need more roughness. Maybe this is even too much, but yeah, something like that should work. So yeah, this is the value at 0, so no anisotropic effect at all. But then we can go to 1 and get this horizontal deformation. In this case, the specular gets stretched. It happens in a relation of the curvature of the surface. So we can see some more irregular specular reflections. And of course, we can just do the opposite and make it stretched vertically. So we can also rotate the effect. To be able to see that more clearly, I'm going to hide the statue so we can see the effect only on the sphere. So let's set the anisotropy back to 0 and unhide our statue. Sheen is used for materials like clothes, velvet, and basically we can define a color and also the roughness for the effect. If we set the diffuse to black and the specular to 0, we will only see the effect of sheen. So yeah, we can change the color and change the roughness value and get some totally different effects. Let's get rid of the sheen effect and reactivate the specular and also lower down the roughness a little bit. So now we're going to describe the index of refraction value, which is very, very important to control how the reflection behaves on the material. The index value controls the reflection strength on the surface based on the Fresnel effect. With a value greater than 1, reflection is strongest on the surface parts that turn away from the viewer's angle, the gazing angles, while the reflection appears weaker on the surface parts perpendicular to the viewing angle. You can simulate metals using the glossy material, increasing the index value to its maximum. Then you would be able to change the color and then and also, yeah, the roughness and get the needed result. The best method to simulate metal is to use the metal material, of course, or the universal material, which incorporates all the metal material functions. So we will, of course, talk about it. Another feature of the glossy material is the film width. You can use it to simulate the look of thin film material on a surface. And also you have the film index that helps modulating the effect. So let's take a look at film width using a totally black surface, and change the index to a normal value, 1.45, and yeah, film width. So as you can see now, I'm creating this rainbow effect on the surface. It's totally visible on the specular, so if we increase the roughness, we're going to make it even more evident. And the film index helps modulating the effect. We can combine it with the color, absolutely. With specular at 0, you will see no effect, since film width is only visible on the specular. So next, let's add a specular material, which is used to simulate transparent materials. Before proceeding, let's activate the Octane Denoiser. So from the camera imager, we can activate the denoiser, and we also need to activate the proper pass for the preview, so the denoiser beauty pass, and we're basically ready to go. So now the denoiser will do its job just after some samples will be fired. So first I'm going to change the model to GGX, and we can start taking a look at what reflection and transmissions are doing for the material. I will turn off transmission, so we can now see only the reflection effect. We can change the roughness. So now basically our material is not transparent at all. But we can adjust, the roughness of the reflection, and also, work on the anisotropy, on the rotation for the anisotropy. Well, let's leave it to 0 right now. Also, the index is important, and it's important for both the reflection and transmission. So let's do the opposite. Let's just turn off the reflection completely, and let's turn on the transmission. So now the roughness is pretty high, but even in this case, you can just operate on the transmission roughness in this case. And also the index is very important. So if we set it to 1, we basically have no refraction. If we start increasing the value, the refraction is going to be stronger and stronger. So let's leave it at 1.45, which is, the value normally used for glass. And let's turn on the reflection. So now we have both reflection and transmission active. We can change the color for the transmission, and we can also change the color for the reflection. There's really, a lot of control for this kind of material. So let's go back to to basic values. Okay. We can also use the dispersion coefficient, which is pretty important when you want to reproduce a realistic transparent material. It's something quite heavy to calculate in general, and you never need to raise the value too much. Look at what happens when you set it to 1, for example, or even 0.5. We get some pretty high dispersion. So even a value of 0.05 is going to be quite good. And yeah, so this is the dispersion. Let's get a little less reflection here. Also, we have other options in this material, like fake shadows. You know, normally if you put like an emissive object inside a transparent object, you don't get the emission to reach what's outside the object. That's what fake shadows is for. We will take a look at this in future videos, but yeah, it's an option basically used for architectural scenes where you need light coming from outside to pass through windows. Then we have thin wall. Thin wall, it's an option that basically makes the material look like has no volume, no thickness at all, and appear more like a thin film object. So let's turn off the dispersion. And yeah, so we can see that now the material is not showing any refraction at all. The last material we're going to describe in this video is the metal material. So let's add the metal material. Let's attach it. We can get rid of the specular material. And let's analyze the options the metal material offers. So we have 3 different methods to deal with metallic material definition. I'm going to set the model to GGX again. And yeah, let's start with artistic. So we have several attributes here. We have the specular that controls the reflection. We have the roughness that controls the roughness of curves. Let's keep it at 0.2 or something like that. And then we have the diffuse here, which is, strange for a metal which normally has no diffuse at all. But, we can assign a diffuse color to a metal and, blend the diffuse with the specular, with the reflection, basically. So if I add like an RGB color and attach it to the diffuse, even if I change it, well, nothing happens. If I attach the same node to the specular, I can control the specular color. Okay. There is this specular map option here, which is very important to mix the values. So let me duplicate this. I'm going to change the color to like blue and attach it to the diffuse. So if I now attach the noise texture to the specular map, I can use it to blend the diffuse and specular color this way. So now I have, control over the metallic color and the albedo color independently. Let's change the contrast here to something like 0.5 or maybe 5 more. Okay, let's leave it like that. So it's very important to understand that the specular map needs an input if we want to mix diffuse and metallic into the same material. Let me change the colors to something a little different, more pleasing for me. Yeah. And okay, so this is the artistic method. Now let's try the IOR plus color method. So in this case, as you can see now, the color we assign to the specular input doesn't look to affect the material anymore. That's because now we need to use the first two values of the IOR red channel in this case, which is, it's not about the color right now, because with this method we're just changing the index, the reflection index. So I can now control how this color is reflected, basically using those two values. So this is the big difference. I have more control on the refraction. But the color is still controlled by this node. Okay, so that's it for our second method to define metals. I'm going to change the color to something more evident. Yeah, more saturated. And let's choose RGB IOR now. So as you can see, if I set the IOR value to 0, the color here is not affecting the metal at all. Even if I, change those values, we're not getting that exact color defined in the color node. That's because we're now controlling the color of the reflection and the way each color component is reflected using the first two values in each index here, RGB index. You can find those values online. This website is basically perfect to find which values we need to use to simulate realistic metals. So you can find the first two values for each index we need to input in Octane to get what we need. So let's say we want to simulate a gold metal material. Well, I'm going to just detach all those nodes and set the IOR to 0 for all those 6 values. And then I'm going to copy the values I can find on the website I have been showing you. So 0.18299 and 3.4242, and then 0.42108 and 2.34590, and for the last two values 1.37340 and 1.77040. So as you can see now, we have a pretty realistic gold metal material without any color node attached. We're just controlling the metal reflection using real refraction values. So that's pretty cool. Last but not least, we have the universal material, which is basically the one I use more often. because it incorporates all the materials I just showed you. So, it's basically the Octane version of the Disney principled material, and it's so useful. And we will describe it in one of the next videos. But, if you've been going through all this long video, you probably will be able to, to use it without problems, because you will find the same options you can find in the other materials into the universal material. That's all for now. I hope you found this video useful for you, and see you next time. Cheers!